Alright, solving quadratic functions by graphing. We only have the one goal, which is to solve quadratic equations by graphing. So our functions and equations, we're going to call them the same for now. Two vocabulary is quadratic equation or function, and then of course what is a double root. Okay, on the left hand side here we have a quadratic equation because it's y equals and not f of x equals. As soon as we put the f of x in there on the right hand side, we have a quadratic function. So y and f of x are the same thing. They're both output values. It's just one is written as an equation, one's in function form. The zeros of a function, or roots, they represent the x-intercepts on a graph. They're also called the solutions to the function or equations. Now quadratics can have 0, 1, or 2 solutions. If you look at the first graph here on the left hand side, this one has two real solutions, which are found right here and right here as whatever those numbers are. So since the axis of symmetry is through the vertex, if this happened to be a -3, then this one on this side would also be a +3. Now over here in the middle, we have where the graph, the vertex of the graph anyway, bounces off the x-axis, creating a solution right here. This is actually one unique real solution, but this goes by a special name. It's called a double root, which we have written down here. It's when the vertex of the quadratic lies on the x-axis. Two roots of the quadratic are the same number. So if this happened to be, let's say -2, well, the -2 came up twice in the solution. So we see it's only one real solution by itself, but it's actually two solutions. It's called a double root. Now on the right hand side here, if your graph does not have any x-intercepts, then there are no real solutions. So we're going to look at solving a quadratic with two real roots on a graph. So the first thing I got to do is make sure that the y value or the f of x value is equal to 0, because they are called zeros of the function because when you put a value of x in, they output a 0 for y. So we want the y value over here to be a 0. And the first thing I want to calculate is the axis of symmetry. And the axis of symmetry again is -b over 2a. So my a value is -1, my b value is 4, and my c value is 5. I found those numbers here, here, and here. So the axis of symmetry is going to be the opposite of the b value, which is 4, over 2 times the a value, which is -1. So this comes out to -4 over -2, which is just 2. Now that means that I have a vertex that's somewhere along this line. I don't really care where the vertex is. What I want to find out is where does this graph intersect the x-axis. The vertex could be right here, or the vertex could be right here, but the graph is going to curve downwards because the leading coefficient is negative. I want to find out where does the graph actually cross the x-axis. Now the first point I'm going to test is the y-intercept. The y-intercept is going to equal 5 because that is the c value. So the y-intercept is actually right here. So I know the graph is curving down this way, and I want to find out where over here it curves. So I got to pick some other values that go past 0 for x. So let's say I choose a 1 for x, and I'm going to put a 1 in place of x into the equation. I'm going to find out what it outputs. So I'm going to put a 1 here and a 1 here. And actually it's a -1 because I'm putting a -1 over here. So -1 squared is 1. 1 times a negative is -1. And then 4 times a -1 is -4, and then plus 5. So I end up with -5 plus 5, which equals 0, which means my dot actually does intersect right here on the graph. So my graph was curving something like this. I don't care where the vertex is. I just want to find out where it crosses the x-axis. So I know it crosses right here. So one of the solutions is -1. So x is going to equal -1, comma. Now I got to find the other solution, the solution that's on the right hand side of the graph. Now I don't have to substitute values back in because this graph is symmetrical around the axis of symmetry. My axis of symmetry is here, so this solution is, you can see, 3 units to the left. So the other solution is going to be found 3 units to the right, which is right here at 5. So if I were to put a 5 in place of x over here and here, I will have an output of creating a 0 or a solution to the problem. So here are my two solutions, -1 and 5. Now their ordered pairs are actually -1, 0, and the ordered pair of 5, 0. But again, the solutions are just the x coordinates of those intercepts themselves. Okay, for our next one, we're going to solve with a double root. Now, what you'll notice over here first is this is not equal to 0. So I got to force this to equal 0. So I'm going to add 16 to both sides. So I have x squared minus 8x plus 16 equals 0. So now when I identify my a, b, and c values, my a equals 1 from here. My b equals negative 8 from here. And my c value is now 16, which is here. So I want to find my axis of symmetry so I know where I want to go for my next point. So my axis of symmetry is going to be the opposite of b. So the b value is negative 8. So opposite of negative 8 over 2 times the a value, which is 1. So I end up with negative times negative is a positive 8 over 2, which is just 4. So my axis of symmetry is going to be right here. And I'm actually going to go ahead and calculate where the y value of the vertex is going to be, because this is a double root, which means it should be right on the x-axis. So I'm going to put a 4 in place of the function. So 4 is going to be squared minus 8 times 4 plus 16 should equal 0. So I'm going to put the axis of symmetry value of 4 in there. So that gives me 4 squared, which is 16. And then negative 8 times 4 is negative 32. And then plus 16, you can see that is actually going to come out to 0. So my vertex is right here. And my graph is going to curve this way. And because the vertex is right on the x-axis, that has a double root. And the solution is x equal to 4. And we call it a double root because the vertex is right on the x-axis. Now they want us to solve a quadratic with no real solutions. And this looks like it's supposed to be... Right, you know what, we got an actual error here. This is supposed to be negative 2x squared minus 4x minus 3 equals 0. So that's actually incorrect. So let's use the a value of negative 2, the b value of negative 4, and the c value of negative 3. So let's find the axis of symmetry so I can find my vertex. So x is going to equal the opposite of b, which is negative 4, over 2 times the a value of negative 2. And that's going to give me a positive 4 over negative 4, which gives me an axis of symmetry of negative 1. So the vertex is found at negative 1 and then some value. So somewhere along this line is my vertex. Now, how do I find the vertex? I just simply substitute this negative 1 into the problem. So I have negative 2 times x to the second minus 4 times x minus 3 is going to output the y value. So I'm going to input my negative 1 here and here. So negative 1 squared is 1. 1 times negative 2 is negative 2. And negative 4 times negative 1 is going to give me a positive 4. And then, of course, I've got a minus 3. When I combine these together, I get a positive 2 minus 3, which is a negative 1. So my vertex is located at negative 1, which is right here. Now I know that because my a value is negative, my graph is going to curve downwards like this. So my graph is going to curve somewhere this way. So I don't even have to find any other points of the graph to know that there's going to be no solutions. Okay, for this last example, they want us to approximate roots of a quadratic function. And what we have here is Ted Williams hitting his world record home run. And according to the equation right here, this equation represents the flight path of the ball. So if we look at a little sketch up here, this 1.5 represents the starting point where he hit the ball. I think this is in meters. Yeah, it's in meters. So he hit the ball at about 1.5 meters above the ground. Now the graph was continuing up like this, going up, and then the ball was coming back down. Now the x-axis here, according to what they're saying here with this t value, is representing seconds. So that's in t, time. So the y-axis up here is actually h, or height, above the ground. And what they want to know is if it falls to the ground, and because of gravity it will, approximately how long will the ball be in the air. So we want to know what the time is all the way across here until we hit the x-axis, also called a zero of the solution. In other words, the h will have to output a 0. And you can see right here on the h values, they start at 27.96 meters at 6.3 seconds, And then at 6.8 seconds, it's negative 24.34, which means it's already passes the ground level and it's continued on as if it went through the ground. We know that that can't happen. So what we have to do is substitute these values here into the function to see which one comes out closest to equaling 0. So that's what I'm going to do now. Okay, so right here, I've gone ahead and set up the equation waiting to input all of these different values of time. So the first one is going to be 6.4 and 6.4. Now you're going to want to use a calculator to calculate this here. And I've gone ahead and calculated this already. And that value equals 18.14 meters. Now remember, we're trying to find out where it equals 0. So 6.4 seconds is not long enough in terms of flight time. So I'm going to try the next one. I'm going to put 6.5 into the next one, 6.5. And that's going to equal exactly 8. So what this is telling me is after 6.5 seconds, the ball is still 8 meters above the ground. So it's not quite at 0. So I think the next one's going to get me past 0. So I'm going to substitute in anyway. 6.6 and 6.6, and that's going to give me negative 2.46 meters. So this is as if the ball went into the ground, 2.46 meters. We know that can't happen. So where does it pass 0? Well, it passes 0 somewhere between here and here, which means it's somewhere between 6.5 and 6.6 seconds. So 6.5 through 6.6 seconds. Now, if you want to say somewhere between 6.5 and 6.6, that's perfectly fine. However, if you wanted something maybe a little bit more precise, you can see that this number is closer to 0 than 8 is, which means it's the answer, the true answer is going to be closer to 6.6 than it is to 6.5. So if you wanted to estimate it, you could probably say it's around 6.58 or 59. Either one of those answers will be okay.